This video is going to be a game changer because this is my ultimate guide to trig integrals. First, we'll be talking about what I mean by the integral ready form, and then we'll be talking about the trig identities that we need so that we can simplify an expression into one of this form and integrate. And then we'll be doing 20 examples on just trig identities. Make sure you guys go check out my Patreon so you can get today's notes and also the practice questions. And now, here we go. Integral ready form. We like to integrate sine of ax and also cosine of ax. Notice, they are both to the first power, and then the a right here is just a non-zero constant. Then, sometimes you might be able to pull out one of the sine x factor. Then in that case, hopefully, this right here is going to be an easy enough expression in terms of cosine x. Because this way you can just let u equal cosine x, and the derivative of cosine x is just negative sine x, and the sine x will cancel. So u sub will help us finish that. Similarly, if we can get cosine x on the outside here, then what do we want to write here? We would like to have an easy enough expression in terms of sine x. And then just proceed by doing u sub. Okay, then secant square x, secant x times tangent x, they are also integral ready because to integrate secant square x, just ask yourself, the derivative of what will give you secant square? And the answer for that is just tangent x. And the integral for this is again, the derivative of what will give us that? The answer is secant x. Now, if we have an expression that you can pull out the secant square x right here, then we hope that this right here is an easy enough expression in terms of, if we want to do with u sub, then we have to ask ourselves, what derivative will give us secant square, right? And the answer for that is tangent x. Yeah, in this case, you put u equal tangent x and then proceed by u sub. Now, if we can get secant x times tangent x on the outside, then this right here should be in terms of secant x, and then just let u equal to that. Now, after that, tangent x and secant x, they are also integral ready because we do have the standard answer for the integral of tangent x and also secant x. Make sure you guys go check out my other videos for a detailed explanation. So, keep this in mind, and notice you might be wondering, why didn't I put down cosecant and also cotangent? Well, they are very similar to secant square and also secant x, tangent x, very similar. And usually I just go over this right here with my calculus 2 students. For cotangent, cosecant, not so much. Here though, let's talk about the identities that we must know. First, have a look. Sine square x. Of course, we know that's the Pythagorean identity. Usually we can just go from sine square x to 1 minus cosine square x. Similarly, cosine square x is equal to 1 minus sine square x. But this is not integral ready, and this is also not integral ready because we like to have sine to the first power, right? So make sure you also know the other version for sine square x. For the first one, this right here is 1/2 times 1 minus cosine of 2x. And notice this right here is cosine to the first power, and then a constant 2 times x. And of course, you can distribute the 1/2. The constant multiple, you don't have to worry too much in terms of integrating any of that. Now, if you have cosine square x, this right here, we can also write it as 1/2, 1 plus cosine of 2x. Notice here right here, it's plus, but here is a minus. Now, for sine of 2x, I know this is integral ready, but sometimes you'll be dealing with problems that have a different angle than just an x. You have to make sure that the angles match. So right here, the double angle identity, keep that in mind, is 2 sine x times cosine x. And then for cosine of 2x, in fact, there are 3 versions of it. I'm just going to write down cosine square x minus sine square x for you. And then you guys can check out the other versions and can think about what other versions are. Okay, to continue. let's talk about tangent x. Well, just like what I said earlier, it's integral ready, and if you want to do the integral for tangent x, well, you can start off by saying that's sine x over cosine x. And then you can put the sine x to the outside here, and then the first expression is just 1 over cosine x to use up. Now for secant x, I know that's 1 over cosine x. However, if you want to see a standard way of doing secant x, make sure you check out my other video for it. This is what I really want to talk about when we have tangent square x, because this is not integral ready. Well, to simplify it, it's really just the Pythagorean identity. You can change that to secant square x minus 1. Similarly, secant square x, in fact, this is the same as, you can say tangent square x plus 1. Well, 1 plus tangent square x, the order of addition doesn't matter. So this is usually what I cover. However, if you are dealing with cotangent and cosecant, just make sure you follow the similar strategy and then these identities. For cotangent, write it as cosine x over sine x. For cosecant x, well, that is 1 over sine x. For cotangent square, guess what? That's pretty much this version, but instead of secant square, you will get cosecant square x minus 1. And then if you have cosecant square, that's very similar to that. Instead of tangent square, you will have cotangent square x plus 1. Just like all this. Ready? Now, let's go ahead and do the 20 problems. Okay, let's look at the first one. We have sine squared x. This is not in the integral ready form because we have sine squared x and there's nothing else. So what do we do? Make sure you don't change this to 1 minus cosine squared x. That's also with a square, right? So instead, let's go ahead and change this to 1/2 times 1 minus cosine of 2x. So that we'll just be working with the first power here. And remember, we can totally integrate cosine of a number times x. Multiplying the 1/2, you get 1/2 minus 1/2 times cosine of 2x. And that is the integral ready form for sine squared x. Number 2, let's look at sine to the third power x. Earlier I didn't give you any identity with the third power, right? Well, all the identities I gave you was the second power. So why don't we separate it? Let's separate this as sine square x and then take out one of the sine x here. Together, we have the third power. Now, because we have the sine x factor here, so that means we want the first part here to be an expression in terms of cosine x. Make sure it's cosine x. The angle has to match. So do not use this formula anymore because we have cosine of 2x. Instead here though, we will be using 1 minus cosine square x. Because this way, we can let u equal cosine x, just cosine x. And then proceed from there. The derivative of cosine x is negative sine x, that can cancel with that. So this is our integral ready form. And again, make sure that you keep in mind this notation means we have cosine x to the second power. So this is what I mean by an easy enough expression in terms of cosine x. Now we did the second power and also the third power. Why don't we look at the fourth power? Again, we don't have cosine x in the equation, huh? So what do we do? Do we want to separate it to sine to the third power x times sine x? Well, not really, because if you look at this and try to write this in terms of cosine x, it's going to be pretty hard because you would be dealing with like the, this is the third power. We need a second power, right? No, don't do that. So instead, we are going to be looking at this as sine square x and then squared. Remember, I gave you guys the identity for the square. And then the fourth power is of course the square and then square. Now, we are going to try to reduce the power just like the first one. So we will be using the same identity right here, which is 1/2 times 1 minus cosine of 2x. Okay, square the 1/2, we get 1/4, and then we multiply. We will have to square this. So remember, this is in the form of a minus b squared. So we will first have 1 squared, right, the a squared, which is 1, and then minus 2 times ab, which is just that. And lastly, we have to add this thing squared, which is cosine squared of 2x. So definitely remember the identity that a minus b squared is equal to a squared minus 2ab plus b squared. And that's what I did right here. Now, we can multiply in the 1/4, but the problem is that this right here is to the second power. That's not what we like, right? So what do? Earlier we used the sine version. Remember, there's also the cosine version. It's just that instead of the minus, you will have the plus. For the cosine version, I will write it down here. Cosine squared theta. I'm using theta here because here we have the theta being 2x. This right here is equal to 1/2 times 1, and here we have the plus for the cosine. And then we still have cosine of 2 times whatever that angle is. Okay, so I'm going to keep this right here, and we will have 1/4 times 1 minus 2 cosine of 2x. But for this right here, I'm also going to be distributing the 1/2. So 1/2 times 1, and then 1/2 times that. And then remember, theta is 2x, so this is cosine of 2 times 2x. And I'll put that as 4x later on. Now have a look. This is 1/2. We can combine them, which is just 3/2. So 1/4 times 3/2, and then just again write down the rest. And then finally, I will just distribute the 1/4. This times this is 3/8. This times this is minus 1/2, and then still the cosine of 2x. This is integral ready. And then finally, this times that is plus 1/8 cosine of 4x. Now we can just integrate this, integrate that. So this is the integral ready form for sine to the 4th power x. Okay, for number 4, we have sine to the 3rd power x times cosine x. Do we have to do anything? No, this is already integral ready. Why? Because we have the cosine x factor right here, right? And this is being multiplied with an expression in terms of sine x. This means sine x to the 3rd power. So proceed by letting u equal sine x, and then you can go from there. Number 5, what if we have sine square x times cosine to the 3rd power x? What do? When we have different powers, I will tell you, go with an odd power, which is in this case here, right? I'm going to take out one of the cosines. Right here, this is still going to be the same. Write this as cosine square x times cosine x. Now, the idea is that once we have the cosine x right here, we want this part to be an expression in terms of sine x. This is good, keep that. This is not good, we will have to change it. Change it to not the power reduction though, because otherwise you get a different angle. Instead, you write it as 1 minus sine square x. And now you can see that this is the expression that's going to be in terms of sine x. Of course, you can multiply in the sine square x. So we get sine square x, and then minus sine to the 4th power x. like this, times cosine x. And you proceed by letting u equal sine x. Okay, number 6. Here we have, this is a hard one, sine square x times cosine square x. Because I didn't have an odd power here, right? So we couldn't do this as easily as number 5. So what do? In this case, you will have to do the power reduction, but before that, this right here, both of them are with the second power. We can write this as sine x times cosine x and then raised to the second power. Here though, you can use the power reduction that what I showed you earlier, or you can also do the following. Check this out. Note, when you have sine x times cosine x, that kind of reminds you of the double angle identity for sine, yeah? Because if you have sine of 2x, this is the same as 2 sine x times cosine x, isn't it? Which we see this part. So if we divide both sides by 2, then we can get this being equal to 1/2 of sine of 2x. This is the same as that. And then go ahead and square that, which means we have 1/4, and then this means we have sine square of 2x. This is not good because we have the square, right? So what do? Power reduction here. And reminder, we have the following. When we have sine square of the angle theta, this equals 1/2 times 1 minus, and we have cosine of 2 theta. Here the theta is 2x. So we have 1/4 times this part, which is 1/2 minus 1/2 times 1 minus cosine, and then we have 2 times 2x. Okay, and now this right here is just 1/8. And then 1/8 times 1 is 1/8. 1/8 times this, which is minus 1/8. And then we have cosine of 4x. And this is the integral ready form for that. Number 7, sine of 2x over sine of x. Now, the biggest problem with this right here is that the angles are different, but this is going to be an easy fix. Because sine of 2x, that is just 2 sine x times cosine x. And the bottom stays the same. Now, they're just multiplying on the top, so we can cancel out the sine x. And we just get 2 cosine x. And then we're done. That's the integral ready form. Number 8. If we have sine x times cosine of 2x, again, the angles are different. So what do we do though? Yes, we have the double angle identity for cosine, and remember there are 3 versions. Earlier I wrote down cosine of 2x. This right here is equal to cosine square x minus sine square x, right? But if I put that right here, we have the sine x factor in the front. U sub is not going to help, right? So, since we have the sine x already, we want to write this in terms of cosine x. That means I want to keep this, so I want to change that. Check this out. Keep this, and change this to 1 minus cosine square x. So, this is cosine square x minus 1 plus another cosine square x. 2 of them right here. So that's another version for the double angle identity for cosine. This is what we're going to use though. Let me just put that down right here, and then the sine x factor right here. This part is this 2 cosine square x minus 1. If you want to integrate this, go ahead and let u equal cosine x, and you can proceed from there. Integral ready form. Number 9. Here we have sine to the third power x over cosine of x. And they are both with an odd power. In that case, go with the one on the top. Break it down. Write it as sine square x and then times sine x right here. Just put one of the sine x on the side. And then we still have the denominator cosine x. Here, since we have a sine x factor on the side, that means this right here should be in terms of cosine x. So this is good, but we will have to change that. Change this to 1 minus cosine square x over cosine x, and then sine x. Okay, you can do a u sub now, or you can simplify this a little bit. You can write this as 1 over cosine, and then minus cosine square x over cosine x. When you have one thing on the bottom, you can separate the fraction like this. And right here, you want to see the cosine for u sub purpose, so I will keep this as 1 over cosine x. And then this right here reduced to cosine to the first power x. And then now you can say u equal cosine x. Now number 10, we have sine x plus cosine x, and then squared. Because we have a plus in between, so when we square that, make sure we do the first term squared. So that's sine square x plus 2 times this and that. So that's 2 sine x, cosine x. Lastly, we add this square, which is cosine square x. Now, what can we do? Well, this is so nice, right? Because we have the sine square x plus the cosine square x. This is a plus. Together, they add up to 1. And then plus in between. Now, this is also very nice. 2 sine x, cosine x. This is not in the integral ready form, but if you put this into the double angle identity for sine, you get sine of 2 times x, which is integral ready. Yeah, go ahead, integrate this. Now, continue. Number 11, here we have sine x times tangent x. Well, we do have a sine x factor, but this is tangent. So maybe we can write this as sine x over cosine x. Okay, let's give that a try. We do have a sine x factor. Can we write this in terms of cosine though? Yes, it's actually possible, but don't do it. Because here's the deal. If you look at this, we know sine square x is equal to 1 minus cosine square x, right? But this is only to the first power. You will have to take the square root and then do the plus or minus. Do you really want to put this on the top? No, not a good idea. So we are going to approach this slightly differently. Multiply the top. This right here becomes sine square x over cosine x. So far so good. Now, for sine square x, we can write that by what I told you earlier. This is 1 minus cosine square x. And then just go ahead and divide it by cosine x here, and then divide it by cosine x here. Remember, we don't have an extra sine x factor anymore. So in this case, I am actually going to write 1 over cosine as secant. Because this is also integral ready. And then reduce this, that's just minus cosine x. So go ahead, integrate this. And now, it's a good time for me to remind you guys that if you are integrating secant x, the standard answer for that is ln absolute value of secant x plus tangent x. Now let's look at number 12. Here we have tangent square x. Here's the deal. If you remember the identity, you can just go from here to secant square x minus 1, because we can integrate this and we can integrate that. So this is the integral relative form for it. Now to see why, you can first write this as sine squared x over cosine square x. And then it's kind of similar. The top right here is 1 minus cosine square x. This time we're dividing by cosine square x, and then right here do the same thing. This right here gives us secant square x. This right here gives us the 1. And remember, when we integrate secant square x, you ask yourself, the derivative of what function will give you that, which is tangent x. Okay, for number 13, we have tangent to the third power x. And I will give you guys two integral relative forms. The first one is with sine and cosine, and the second one is with secant and tangent. If you do this with sine and cosine, you write this as sine to the third power x over cosine to the third power x. They both have an odd power. Go with the one on the top. Take out one of the sine factor. So we get sine square x over cosine to the third power x, and then right here times the sine x right here. Now, because we have the sine x factor, can we write this part in terms of cosine? Yes, and the expression is going to be quite nice because we have sine square x. This right here is 1 minus cosine square x, and then go ahead and divide this by cosine to the third power, and likewise here. And then multiply that by sine x. And again, we have the sine x factor here, so we want to keep this in terms of cosine x. Do not change this to secant to a third power. Just go ahead and write this as 1 over cosine to the third power. And this right here, reduce that, we get 1 over cosine x. And then we have the sine x right here. And then you can proceed by letting u equal cosine x. Now, if you want to do this with tangent and secant, well, this is tangent to the third power, and the identities I gave you, they are with the second power, right? So let's first write this as tangent square x times tangent x. And we have the tangent square x, we can change that to secant square x minus 1. Here though, we're not done yet, because do not let u equal secant x, because this is just a tangent x on the outside. So you have to keep in mind, if we have an expression of tangent x, that's not one of the integral relative form. But instead, we want to have something like this. An expression in terms of tangent, right? In terms of tangent, and then on the outside we have a secant square. So what we want to do right here is, we will have to distribute the tangent x. Let me put this down right here. This is precisely tangent x times secant square x. And that's exactly what we have right here. And then this times that is minus tangent x. Right here, you see, go ahead, let u equal tangent x. The derivative of tangent x is precisely secant squared. So it works out nicely. And right here, tangent x is also integral already. And let me remind you guys the standard answer for the integral of tangent x. This right here is equal to ln absolute value of secant x. Okay. Now for number 14, here we have tangent to the fourth power x. Right here, I'm not going to do sine to the fourth over cosine to the fourth, because if we take out one of the sine x factor, sine to the third power, it's hard to write it in terms of just a cosine x in a nice form. So let's not do that. Right here, we need tangent and secant. So I'm going to break it down as tangent square x times tangent square x. Notice I didn't write this as tangent square x square. The reason is because I really want to work with a tangent factor, even though it has a square. Now, what do we do? Well, I'm going to look at this right here. I'll change it to the secant square x minus 1. Okay, we have a secant square x. Remember, the tangent is good. So distribute this now. This right here, we get tangent square x times secant square x. And this by itself, it's integral already. And then this times that is minus tangent square x. Well, this is not really integral ready yet, but we did an example like this earlier. All we have to do is to use the identity again. So if you rewrite this as secant square x minus 1, you'll be pretty much done. Distribute the negative though, we will get tangent square x times secant square x. This is by itself, integrate that, and then minus secant square x, integrate this. Lastly, minus minus, it's a plus. Just be careful with the sign. This is perhaps the most common mistake, right? People miss, especially if you're taking a test under pressure. Be really careful with it. Now, for number 15, let's look at secant. If this is to the first power, we have the standard answer. If it's the second power, the integral of secant square is just tangent x. If it's the third power, we actually have to do integration by parts. That will be a topic for another video. So let's look at the fourth power. This is similar to the one that we just did. Write this as secant square x times secant square x, so that we can take this and change that in terms of tangent. Have a look. This right here, it's the same as tangent square x and then plus 1. And then here, keep that as secant square. And in fact, this is integral ready. You do not have to distribute. If you do, it's still okay. But notice that this right here is in terms of tangent x, right? Tangent x right here, square, and then plus 1. You can totally proceed by letting u equal tangent x. Now let's look at number 16. If we have secant to the third power x, as I mentioned earlier, you will have to do integration by parts for this. But if you happen to have a tangent x right here, this is much better. What do we do though? Well, we don't have the second power like that yet, so maybe we can take out one of the secant. Have a look. If we take out one of the secant, we get secant square x, and then times one more secant, and then we still have that tangent x. And guess what? We are done, because we can take this into our integral ready form. We can let u equal secant x, and the derivative of secant x is precisely secant x times tangent x, and we just have to integrate u squared. So do not let u equal tangent x, because that's to a third power, but instead if you change that to this, then you can let u equal secant x, and you can go from there. Now let me change the third power a little bit. Number 17, let's look at if we have secant x times tangent to the third power x. In this case, okay, I really cannot produce the secant square anymore. So let's take out one of the tangent. This becomes secant x, and then times tangent x, and then times tangent square x. Here, tangent square x, we can change that into secant square x minus 1. So this is secant square x minus 1. And then this right here, we keep it. Is secant x times tangent x. Integral ready. Just like that. Now, number 18. Let's look at secant to the fourth power times tangent squared. So we have tangent squared. If you want to do like this, secant x, tangent x, secant x, tangent x, you will have to take out a tangent and a secant. Once you take out a tangent, you get another tangent left, right? It's hard to write that in terms of secant. So instead, I would like to take out secant square. So have a look. This is secant square x. Keep that. And then we still need secant square x. Together, we get a secant to the fourth power. Now, because I have a secant square right here that I'm trying to get ready with, so that means this part should be an expression in terms of tangent x. That means this is good, but not this yet. Change that though, we can get tangent square x plus 1. And then go ahead, multiply that with tangent square x, and then we still have the secant x on the outside. So right here you can distribute the tangent squared. So you get tangent to the fourth x plus tangent square x. All that times secant square x. Then we can do u sub, let u equal tangent x. And that is integral ready form. Okay, number 19. Let's see if we have tangent x over 1 plus secant x. We don't have the second power to work with, huh? So let's go back to the fundamental. Let's try to write everything in terms of sine and cosine. On the top, that's the same as sine x over cosine x. On the bottom, secant is the same as 1 over cosine x. Now we have a complex fraction. To simplify that, let's multiply the top and bottom by the cosine x. This times that, we just get sine x on the top. Okay, this times this, we get cosine x plus this times that, cosine x cancel, we just get plus 1. Now, this is so nice, isn't it? Because we can just put the sine x factor to the side and look at this as 1 over cosine x plus 1 times sine x. Like that. Integral ready. Because this is an expression in terms of cosine x. Yeah, just like that. Now, number 20. Here, let's see if we have secant x plus tangent x squared. In this case, once again, let's just expand this. So we get this thing squared plus 2 times this and that. And lastly, we add tangent square x. Here though, we have to be careful. This plus that is not equal to 1. Be really careful. So, what are we going to do? Right here, this is integral ready because we have a secant x times tangent x. The constant multiple 2. It's nice, it's not going to hurt us. I'm going to change this in terms of secant square. Why? Because we can integrate secant square. That's integral ready. So I'm going to just write this as secant square x plus 2 secant x times tangent x. But for this, that's the same as plus secant square x minus 1. So combining this and that, we get 2 secant square x. And then this right here stays, because that is integral ready. And lastly, minus 1. So this is it. So hopefully this video gives you an idea of how to work with trig identities to get into the integral ready form so that you can integrate. Best of luck in your Calculus 2 class. As always, that's it.